And our next speaker is Jason. And some of you may know Jason. He's been on the Prisma team for quite a while. So Jason is a software engineer with a passion for developer experience, system design, and tooling. He's educated in design theory, practice and ethics. And he became fascinated by the systems aspects of software and the community of open source. Over the years, his journey progressed from the front end to the back end, where he has delved into API services, DevOps, architecture, and more. He made creative and leadership contributions in many environments, mostly at startups, and today he leads the developer productivity team at Prisma, responsible for the control plane product of the Prisma Data Platform. And I think probably most relevant for today, Jason is also the co-creator of Nexus, and this is going to be his topic for today. So Jason, welcome.
Hey, thanks for having me. Can you hear me all right?
Yeah, we can hear you great. You are joining us from Montreal, Canada, if I'm correct, right?
Yeah, that's right. It's minus 12 today, which means it's warm.
Ooh, okay. Well, I told our viewers in the beginning, get a cup of tea. I've got one, and I'm really ready for your talk. So I won't take any more time from your talk. Just to our listeners and viewers at home, be sure to drop your questions in the chat, and we'll get to them after the talk. Jason, are you ready to share your screen?
I am. I'll give it a shot here. Slides, video file, share screen.
And also a quick reminder, if you've joined recently the live stream, we also have a raffle going on, which you can join at the link in the chat.
All right, I believe I'm sharing now.
All right, we're going to get this 80s mirror effect.
Yeah, there we go.
Infinity.
Cool.
All right, the stage is yours.
Awesome. So today I'm just going to give a quick talk on Nexus Prisma. It's also going to be a little bit internals. So we'll go with kind of what it is for those that don't know, and a little bit of a demo, but really we'll spend most of the time, or at least some of the time, just on how this is implemented, and kind of give you a sense for what a Prisma generator looks like under the hood. Nexus Prisma is a pretty simple tool. It's pretty accessible. So I think if you've been curious in writing a Prisma generator, but haven't tried yet, Nexus Prisma is not necessarily, it's like potentially a good place for you to just to browse around in the code base and so on. So anyway, we'll dive into that. So what is Nexus Prisma? So the problem space is that it's trying to solve is if you're building a backend that has a database and a GraphQL API, and you are using Nexus for the API layer. So Nexus is a way to build GraphQL API schemas. And if you're using Prisma for the database layer, and Prisma is an ORM for accessing data in a database. So if you've got these two pieces, well, Nexus Prisma, as the name suggests, is a way to sort of integrate these. And what you want in this case is you want some of your API layer to reflect your database layer. And so what that means is you might have schemas and models in Prisma in your database, and you need something that is pretty similar in your API. And you don't necessarily want to rewrite or duplicate all of that. So some kind of linking that you want to express. So the solution in the form of Nexus Prisma is a Prisma generator. And what it does is it outputs a library of pre-configured Nexus object types and object type field configurations. So this makes it pretty easy to quickly plug into your API layer aspects of your database schema. And you can kind of pick and choose and extend or modify. So it's fairly flexible, as you'll see in a little bit. Just as a sneak peek, sort of really high level, what this looks like is you've got a Prisma schema, something probably more complex than this, but say here with like a model user. And you'll have some fields and so on. And these treble slashes, these are, so you can make comments in a Prisma schema with double slash. Triple slash just turns that comment into something that shows up in the AST of the schema file. So generators can pick up on these triple slashes and output it as documentation, say JS doc or GraphQL descriptions and so on and so forth. So you've got your Prisma schema, and then you run Prisma generate, and what you get out of it is this Nexus Prisma library. So this would be in your application code now, and you import from Nexus Prisma something such as user, and this is directly, like the fact that you can import user is because you defined user over here in your Prisma schema. You use Nexus, you sort of do the typical object type, and you start constructing something that's in your API schema. But now you can take the user that you've imported from Nexus Prisma, and you can start to piece together sort of things that were taken from your Prisma schema and put that into your API schema. So some simple things like the model name and description, but then some more useful things like you could just get a field automatically put into your API there. And this will work with like relations and so on as well. And so we'll do a demo quickly of an actual running application showing more or less this. And then we'll dive into the internals. And the internals, we're going to cover some of the things we see in this diagram here. So at a high level, to run through the sort of the diagram, imagine you are here and you're running as a developer, working on your application, Prisma Generate in your terminal. And what sort of starts to happen from there is first the Prisma schema is going to be read from your application, and that's something that just the general Prisma Generate CLI is taking care of. And then it will run through the generators that are defined in your Prisma schema. So Nexus Prisma will be in your will be defined as a block in your Prisma schema, and that's sort of when the sort of Nexus Prisma generator starts to, all of its stuff starts to run. So it has a little CLI. Generators all have sort of a callable binary CLI, and that gets executed. And from there, the generator sort of takes over of all the logic that needs to take place for whatever it is trying to do. So in the case of Nexus Prisma, what that means is, first of all, looking to see if you have a Nexus Prisma kind of configuration for things that you can basically configure Nexus Prisma generator itself, and there's a special file that it will look for if you optionally if you want to do that. Then it will write some generated runtime, which includes some JavaScript and some TypeScript types. And then from that point, you're ready to go. Your application code, wherever that's sitting, will import from Nexus Prisma. And at that point, the generated runtime will also import from some static runtime. So Nexus Prisma is not just a Prisma generator, but it also ships with some sort of just static runtime that is not needed to be dynamically generated. And we actually try to architect the generator to have as little dynamic generated code as possible, just as an implementation strategy. So that's actually, the TypeScript types are really helpful for that, because we can kind of keep the runtime fairly dynamic while making it look very static, because of the TypeScript types allow us to kind of tailor what the API appears to be when you're consuming statically. And then, so then the generated runtime imports whatever it needs from the static runtime, and you're off to the races. Your application is running. So we'll kind of go through some of these blocks in a little bit. All right. So I showed you a little code snippet before of an application source code, but we'll kind of go through now a live one. So what I have on the screen here is a very sort of simple toy app that's just a small server, GraphQL server, with a little bit of a schema here. And there's a Prisma schema. We'll start there. So this is the Nexus Prisma generator block that I was talking about that you would have alongside your typically your Prisma client generator block. Where in this case, I have a local Postgres that I'm connecting to, and that's just, yeah. Normally you probably have an environment variable there, but this is just sort of a quick and dirty demo. Then we have two models in this Prisma schema, just a user with an ID that has multiple posts, which have a title, and that's it. So really, really, really simple. If we jump to the source for this, you'll see that I have Nexus Prisma here, and I'm importing user and post. If I go and peek in what's in there, there's nothing else except for settings, and that's some sort of runtime settings. So I can configure certain aspects of Nexus Prisma on the runtime side, as well as on the generation time, which we talked about, like a configuration file. So when I'm using user or post, you can see here, basically everything I export outside of this, everything I'm exporting from this module will show up in my GraphQL API. So I'm creating a user object, a post object, a query to sort of send in read operations into my API, and also mutation to send in some to change things, to create a user in this case. So when I'm creating a user object, normally you might do something like, okay, I want to have a user, it's going to have posts, and then I'm going to say, okay, the type here, and then you have post object, and you might say, okay, this is actually going to be a list, and then I'll make a resolve, and here I will get the context, and with the context, I'm going to then access the Prisma and get the user and find many, right? And so you might write something like this, probably in practice with a lot more going on, like authorization or whatnot. But generally speaking, you might kind of have various fields on your models that are being implemented. With Nexus Prisma, you kind of just get that for free. So with the user, you get generated based on your Prisma schema, the description that you put, if you put any. You can see here it's statically typed as undefined because I have not put a description on top of my model. You get the name, you get ID, you get posts. And these are fields, actually. So the $sign here is just a prefix convention to avoid namespace collisions, because you might have a field on your model called name, or you might have a field on your model called description, but you can't actually put $signs in prefix position of Prisma model fields. So this guarantees that we'll never have a collision with user space field names. And so these fields here are then in turn just GraphQL object type field configuration. So here I've got for an ID field, its description. Again, it's undefined because I didn't put that in my Prisma schema. I've got the name, resolve, and type. And so resolve tends to be the more interesting one, at least from sort of, like a lot of this is just pretty static. Like name will be a string, type will be a string, description will be a string, but this resolve is actually a function, and that sort of gets auto-implemented for you. Now for scalars, usually default resolvers are sufficient in a GraphQL API, so there's not too much you need to do for scalars. But having resolvers are pretty handy for relationships. So for example, in the user, what we had before, user posts, the resolve function for posts would actually involve using the Prisma client to query the database to go get all of that user's posts. And so you don't have to really think about that when using Nexus Prisma, which can be a really, this can be good for prototyping. In some, we at Prisma on the Prisma Data Platform, we have a GraphQL API, and there are some relations that are just simple, and we're able to rely on the defaults that Nexus Prisma provides. So but you can pick and choose, and you can also override. So for instance, if in this field, I want to use what we get from Nexus Prisma, but I do need to have a custom resolve, that's pretty trivial to do. I just would put the resolve method below the spread, and now I get everything this Nexus Prisma gives me, but I'll be able to customize resolve. And if I want to sort of wrap the resolver, that's also trivial. I would just access the post resolve, and then here, args, put that in, args, and now I can do some stuff after. I can do some stuff, I can do some stuff before, I can do some stuff after. I can capture the result, return the result, and I'm still completely leveraging what Nexus Prisma gave me, but also doing whatever extra logic I need. So there's a lot of flexibility here. One of the design principles of Nexus Prisma, the new one, because there was an older version in the past, is to sort of give you more static primitives that then you can put into higher levels of abstraction in your own code. Okay, just to make this run, I'll show you a couple little tweaks here. So we talked about the triple comment, so let's give that a shot. So in here, post, I'm going to say this is post, period, save that. this also going to give you a sense of the workflow. So here I've changed the Prisma schema. So what I need to do now is rerun the Prisma generators. So let's run yarn Prisma generate. And then I will restart my server. I guess I could have done that in a separate terminal, but whatever. And now if I come back to, that was on the post. So if I come back to the post and say I want to take advantage of that description I did, you see also the static type is now a string. Whereas if you compare with name, let's see there, this description there is still undefined because we haven't put a comment on that. So just takes an extra Prisma generate to once you change your schema, just Prisma generate and you get that back. Okay. At this point, what I think we can transition to then is now you have a sense of this. It's pretty easy to just try it out for yourself and kind of go. There's a website nexus.prisma.io, and you can kind of explore some of the other features that it has. Like there's custom scalars provided for you. So in Prisma, for example, you can say, say there's a data field, and you could turn this into a JSON. This is made conveniently available for you as a custom scalar in GraphQL from import from Nexus Prisma scalars. And so here we have the JSON. Also gives you some sort of JS doc on what that particular custom scalar kind of is about. And then you've got other ones. So all these custom scalars that Nexus Prisma ships with are the ones that you might find in a standard Prisma schema. So if you are using those, you're good to go already with Nexus Prisma. Saves you a little bit of time. All right. So how is Nexus Prisma implemented? So first thing, if you are curious to go look at the source code at one point, that's at Prisma, Nexus Prisma. Is the repository on the Prisma org. And this is the demo still, so, right? Nexus Prisma. All right. So this is the code base. It's pretty small. And what we're going to try to do is go through sort of how the diagram was in regards to these different steps. So first we said was that CLI part. Then we write some dynamic.
Any chance we can make the font a bit bigger, Jason? Sorry to cut you off.
No problem. Yeah. Is that better? I think that's like hopefully a good compromise because any bigger and I'll have a hard time seeing the files, but I think that hopefully works. Yeah, so we'll go through the CLI and then we'll look at how the TypeScript types and how the JavaScript is generated, what that sort of static runtime is about, and also sort of these parts about the settings that we talked about, this configuration at generate time, and there's also configuration at runtime. All right, so there is a Prisma NPM package called Generator Helper. And so this is sort of like a foundation that you can already use to build a Prisma generator and handle some of the lower level plumbing. We have in the Nexus Prisma codebase, we've got this SRC, everything is in there, CLI, and then we have this Nexus Prisma. And so that's exposed as a bin here, so Nexus Prisma. And it's important that the name here matches what you expect. So this here, Nexus Prisma, is going to be, it's a bin that needs to match what you call in the generator block over here. You see that we have Nexus Prisma, provider Nexus Prisma. So the name of the provider, there has to be, it's going to try to execute something called Nexus Prisma on the path. So this name is basically determines what the provider name is going to be in the user's Prisma schema file. So this CLI, we just start with the generator handler. We have an on manifest that has some boilerplate around kind of what, like for instance, the pretty name. So when Prisma needs to print something in the terminal about this generator, it will use the pretty name. Default output is where should the generator output files to. So there's this concept of the default output. Most of the meat happens on this onGenerate callback. So from the side of Prisma, what we get back, what the generator gets back is what's called the DMMF. The DMMF is basically an AST representation. It's more than an AST. It's partly an AST representation of your Prisma schema, but it also includes what are the operations that are possible on all the models that are in that AST. So user and post and all these different models, and enums. They will support operations like find many, find unique, and these kinds of things. And they'll have fields, and find unique will be influenced, like what you can pass to find unique will be influenced by what are the unique fields in a model, and so on and so forth. So DMMF kind of has a rich set of both AST, but also kind of the CRUD that's possible for your schema. So it can be actually quite a big data structure if you have a big Prisma schema. There's some information about other generators. So for example, we use that with Nexus Prisma to find the Prisma client generator. If we don't find it, we kind of know that you're in an error state, right? You can't use Nexus Prisma without having the Prisma client. So that's one use case for having access to other generators. You get access to the generator that is this generator. So what that means is the generator block for Nexus Prisma in your Prisma schema. This generator is going to get access to maybe how you configured that with a custom output or something like that. And finally, the schema path. So where is the user's Prisma schema on disk? The generator gets access to that. So with these pieces of information, and I believe there's some other things lurking in there. There's some other things, but I don't know details about all those. This is sort of probably the common set that you'll be using. The first thing we check for after validating that you've got your other needed generator is the custom output. So if you're you can output Prisma client to a specific location. You can also output Nexus Prisma to a specific location. That's not sort of the default. The default is to go into Node modules, and you don't really see or think about it as a developer, but that can be controlled. We access the GenTime settings, and depending on where you've customized, if you've customized the output location of your Prisma client, we need to know that because Nexus Prisma needs to import it. So we sort of do some under the hood checks there about that. We load the GenTime settings that you may or may not have for Nexus Prisma itself. So this here goes and fetches the file. And in your and it also runs the settings. This is a settings module, so it's an actual TypeScript file, so it's code. And when that code is executed, it has side effects. If you've correctly used the GenTime settings, it will, because it's been run, it's run by this function, whatever you've the module that you've created. So what that means is the settings GenTime here will be the same setting. It's like a singleton, and that singleton will have been used in your configuration file. And so we rely on that mutation to just transparently get access to anything that you've configured. So for example, we'll find out if you've customized the output directory and if it's absolute or not, and make sure that everything is working well there. Then finally, we get access to what's called the Prisma Client DMMF, slightly different than the generic DMMF. Prisma Client basically has some processing that it does on top of it, very light, but it's still important for Nexus Prisma to know about that version of the DMMF. So we just do that transformation just like Prisma Client does, so that we're working with sort of apples to apples. And then we kind of get to the end, basically, of the CLI, and it's just generate, runtime, and emit. So that's sort of the CLI. Once you get to the generate part, this command here, it basically is going to write, like we said, there's TypeScript types and there's JavaScript runtime. So there's what's called the module generators, which is a separate part of the code base. There's module generators for JavaScript and TS here. And so these are imported into sort of this root entry point of just generate, runtime, and emit. And we go through, create the module for the TypeScript types. We go in and create the module for the There's also support for ESM, so we can output CJS, which is like the old CommonJS require, or we can also output ECMAScript modules so that those can be for imports. And supporting both gets a bit hairy, but as a user, you shouldn't have to think about it. It should just work. So we kind of put in the effort there. And so there's the JS create module. So yeah, like there's a bit of noise here with regards to supporting ESM. Basically, the important part is that we create the JavaScript file and the TypeScript file. These become then emitted to your disk. So the sort of the generate steps already happened here in the create module. That gets us all the content for those files. We just then iterate over the files and output them to your disk. That's basically it. That's the part of this. So if we jump into what does the TS create module do, you can see that create module there receives the DMMF from the Prisma schema that we talked about before, and it also receives settings from the gentime. So depending on some of your unique configurations there, we'll be able to have that when we're generating the modules. The types are concerned with, so there's sort of this long file here where we kind of basically go through the DMF and we're looking at like render TypeScript declarations for enums, render them for your models. We have things like render the Prisma node documentation to description. So all those sort of things we were looking at before, where we were accessing the dollar description and things like that. There is, of course, a runtime correspondence to that, but we do a bunch of sort of static, and this sort of lays out, this is what makes it feel static, is that we're actually going out and putting out the entire API surface statically in TypeScript types. So that's pretty straightforward. It's not that big of it. It's a few hundred. It's about just under 400 lines of code. Then for the JavaScript part, here it's a bit more dynamic, even though it is generated. What's interesting is it's so here it's like a very, you'll see how small this is. Basically, we have some imports that we do, and again, it supports ESM or CJS. We do some imports at the top. Then we access the gentime settings. Now, to access the gentime settings at runtime, what we do there is we stringify what you've configured at generation time, and then we kind of insert that as JSON into the source code. So that's just a little sleight of hand there, and it does limit to some degree what we can do with gentime, because, for instance, you can't like at generate time you wouldn't be able to like pass a function, and that's why there's sort of generate time and runtime settings, and there's sort of two APIs for that, because certain things that what we can put in generate time, we will, but because there are like a function or like a custom instance of Prisma client, for example, you can't pass a custom instance from your generate time, stringify that, and get that back at runtime. So yeah, we try to privilege the gentime config as where sort of as much lives as possible, and then we JSON sort of stringify, insert that into the generated code. Then we just have some DMMF that we also create a variable of, and then that DMMF gets consumed by this JS create Nexus type def configurations. And so this is sort of a more dynamic piece of logic. But you notice that the dynamic piece of logic, all we're statically doing is writing the code that calls it, but that sort of static runtime, it is actually still static runtime that creates the type def configurations over the DMMF. So we're not doing that at generate time. And the reason we do that, and the reason we keep that code static, is mostly for implementation simplicity, so that it's still like, it's not like we have to go print strings and for all this stuff. We still just have a normal project in that regard with like a normal type checking, normal build. So we want to limit this kind of weirdness of the generated like source code to an absolute minimum, and especially for the runtime. For the TypeScript types, we're a bit more. That's what we're kind of leaning more heavily on to make this look really static. But on the JavaScript side, it's really only a couple dozen lines of code that we're generating. All right, I think I'll wrap it up soon. I just want to show a little bit what this create Nexus, what this function looks like. Oh, it's actually in the same module. So this is again static code here. And so what we do with this is we iterate sort of how we did with the TypeScript types. We take the DMMF, we take the settings, and this time we have not just the gen time settings, but we also have the runtime settings. And from there, we're going to, so this is sort of a shallow function that calls out to other functions. We're going to use the DMMF to get all the object type def configurations and all the enum type def configurations. And then from there, you can see sort of what, if you recall the API, you have like the dollar name, the dollar description. You can also see here, let's see, I think the object one is interesting because that's where you have the Prisma client being called. So this is object type, field, name, resolve. Yeah, for resolve, so we jump to that. This is sort of a meteor function. You can see it's a bit bigger. And that's just doing a lot more. Well, first of all, there's also quite a few checks because the resolver depends on you putting your Prisma client instance on the GraphQL context. That's how it accesses it. And if you don't do that, well, if we didn't do any checks, it would just, you get some error like undefined is not a function, right? It's like a very generic and not very useful error message. So we do a bunch of runtime checks here to validate that you've configured your project properly. Currently, you can't disable these, but we will add that kind of as a production optimization where all of this will be just skipped in production. And finally, after those checks, you can see from the DMMF, we've got in what is the model for that's being used. So we access the Prisma. This is the Prisma client instance. We access the model that's being accessed. So now we have that Prisma model. Then we find unique. This is like a quick duck type. So if we don't have find unique, then yeah, this is not going to work. But otherwise, we have a lot of type safety is kind of lacking a lot in the deeper parts of the implementation because it's so dynamic. So this is like where obviously the tests are really helpful for us. Then for the find unique, we do this where unique and reject on not found. We treat that as false so that we don't want Nexus Prisma to be making that assumption. There's a comment in some sort of docs about that. And then finally, for relations, we use the chaining API, which we might switch away from in the future. But basically, once we have a result, we can just access the field name, and we call that. And this is using, I don't know if the Prisma client chaining API is so widely used, but it can be pretty convenient. It's kind of a shortcut for the implementation right now, but we might optimize that more in the future because this does make multiple round-trip calls to the database. And there's cases where for certain kind of relations, like we wouldn't need to. We can do that in one call to the database. But yeah, so some of the more gnarly part of the implementation is in this resolver function. A lot of the other stuff I would say is actually quite straightforward, and it's mostly a design problem space of like, how do you make Nexus Prisma a nice API to consume? But on a technical level, I think it's actually pretty accessible and pretty easy to work on. Okay, I think that's it for my talk.
Thanks, Jason. That was really insightful. And I mean, like, this was the first time for me diving really deep into how Nexus Prisma works under the hood. I mean, I've used Nexus Prisma quite a lot, and I really enjoy it. And I think there's a couple of things that I think would be maybe good for our viewers to emphasize here. And I'd love to sort of hear your perspective on it. So one of the things you sort of went into detail into was the difference between gen time and runtime. And as far as my understanding goes, gen time is what's happening when you're running a development server that essentially looks at your Prisma schema, well, the generated types from the Prisma generator, Nexus Prisma that is, and then it essentially gives you all of that type safety while you're actually writing your GraphQL code. So that means if you basically if you add a new field to your Prisma schema, the dev server of Nexus will basically pick up, oh, there's a new type that has been generated, and it will also give you immediately feedback on that. Whereas runtime really is a lot of the concerns that come from actually the code that you're generating, like a relation resolver that is automatically. Is this a good way to understand this?
I think so. I think that there's even like ways like so for example, there's a one early feature we added was you can choose to how do you want so in Prisma schema you can have IDs on all models will have IDs, but you can choose those to be strings or ints. And then in GraphQL, there's this aspect where there's actually a type for IDs called ID, and it's designed to be sort of slightly different from a string. And so I think we have a pretty easy case there to say, well, we're going to take Prisma IDs that are strings and just going to make those GraphQL ID types. But then for Prisma IDs that are ints, should those be ints in GraphQL or should those be IDs? And we default to IDs, I believe. But we didn't feel like that call was obvious enough to warrant it to be like we basically said, okay, this needs to be configurable. Now, when it came to where do we make this configurable in the runtime or the generation time, because it could work in either. We decided to push it to the generate time, and just to sort of make it because it has sort of like there's like a lower kind of constraints on Gentime, like or rather Gentime has higher constraints, right? It can do less. So by kind of giving it like it has the least power, but it sort of allows the runtime to be more sort of specialized. So the Gentime will be basically necessarily more declarative, for example, and everything there has to be serializable, and everything there has to sort of encode sort of some kind of DSL. The runtime should probably be more minimized, and I think the classic use case is that you want to pass a custom instance of Prisma client instead of using the one that's off the GraphQL context. In that case, we really can't help you with the Gentime config, but where we can, we try to push the complexity sort of down the stack and say, use the Gentime config. But it's a bit ambiguous. There is definitely like a large gray zone there where it could work in either. There's also some things that only work in Gentime. So one example is JS doc. When you want to customize the JS doc, so we, for instance, ship I think like examples. We have some pretty rich JS doc. We also ship like JS doc where if you didn't put a comment in your Prisma schema, we'll give a default JS doc that says, hey, you should like maybe consider putting a comment in your Prisma schema and like make this more useful. But some people might kind of intentionally not be doing that and like don't need that warning. And you wouldn't be able to at runtime configure and disable the JS doc. You actually have to do that at Gentime. So there's basically a sort of a Venn diagram here. There's a lot in the middle, and there's some things that only runtime do, and some things that only Gentime can do. And right now, the bias has been to sort of in that gray zone, we try to push towards the Gentime. Yeah. Does that answer?
And if we were, yeah,
Yeah.
totally. Thank you for explaining that. And if we were to just take a step back before we get into, we have some questions from the audience. If we were to take a step back, I think it's worth also clarifying this. When would someone want to use Nexus Prisma?
So I think it's great for, so first of all, you probably need to know Prisma and know Nexus a bit. I don't think it's necessarily a great tool to learn those. I think just getting experienced with what is it like to use Prisma, like vanilla Prisma, what is it like to use vanilla Nexus? I think those are great experiences to just start out with. Also using Prisma and Nexus works great. And you'll end up, even if you are using Nexus Prisma, you're going to end up using Prisma directly with Nexus a lot anyways. So Nexus Prisma, where it kind of comes in handy is once you kind of know the lay of the land a little bit and you feel like you're ready for a bit more abstraction, and you recognize that your API layer is reflecting, of course, something in your database layer, then you can just start rolling out kind of incrementally fields, relations that you feel can just be streamlined. I think you don't necessarily like you shouldn't feel pressured to or be led down a path which is like replicate your database schema in your API, because that will be very likely not what you end up wanting to do. But I think, yeah, it's a good tool to either for prototyping, then just kind of do whatever and just go as fast as you can. But then in a production case, it can just be kind of a little time saver. And it's much more declarative, right? So like you kind of condense like 20 lines of code down to one, and your whole team can kind of just rally around that convention. It does make things a little bit easier to parse. So, yeah.
Right. Thanks for sharing. So we had Eric asked, can you write a delete mutation? I'm having problems with it. I think this is going to be a bit of a hard one to tackle in this live stream.
Right.
But maybe we can, I can find an example and maybe share that in the chat. And we also had another question from, I hope I'm pronouncing the name correct, Sake Codes. He wrote, very cool, Jason. Thanks for sharing. Is this ready for use in production? Will it keep supporting the latest features in Prisma as Prisma updates? And so you
Yeah.
mentioned this in your talk, right? That we're
Yeah.
using Nexus Prisma.
Yeah. Yeah, we use it, which is a great, like we still consider the library itself to be early access, so to speak. And so for people that, we do that for the community to sort of do due diligence, right? It's not 1.0 yet and stuff, but in our production code for the Prisma Data Platform, we use it. I think it's, it's something to evaluate. In terms of like the direction, it's definitely going to stay a Prisma generator. The API is still evolving, but it's not like going to radically explode and become something else. And what's also, I think, sort of reassuring about trying that library out early is that a lot of it is static. So in the sense of like the types and things. So in a setup, if you're using Nexus Prisma, if you upgrade to a new version or something and there's a couple of breaking changes, like you're going to know about it at build time, basically. So I think it's a fairly safe library to try out, and it doesn't do too much. So I think it's not like you're going into an experimental framework, right? This is really almost there are of course those resolvers, but a lot of it is just data. So it's a fairly safe library, even small library to use. But if you want to like wait for the official 1.0, yeah, then it's not quite there yet, and that might be this year, but it's not like a super high active project that we do at Prisma. It's something kind of a little bit more on the side. So it's hard to say when exactly that certified 1.0 will happen. But,
Thanks for sharing. Anything else you want to share before we wrap up, Jason?
No, I like there's one sort of stealth project I'm working on the side that I would love to talk about, but I can't yet. At least at like in large scale. But I will say that it's revolves around TypeScript and documentation. And I will probably be talking a lot more about it later this year. So you can follow me on Twitter if you're curious about that. And otherwise, thanks for everyone's time.
Jason, thank you so much for joining. It was really great having you and super insightful talk. So thanks for sharing your insights, and we look forward to having you here again.
All right, me too. All right,
Ciao.
ciao.